Ryan Sa, who is going to be talking about this. Welcome.
Cool. Thanks, Alex, for the intro. Yeah. So I'm really excited to talk today about two things, really. So first is kind of the inspiration behind Safety Check and how just at Facebook we figure out how to build products. And the second one is a really interesting technical challenge that came up while building Safety Check that we actually had to solve at scale. And we had to solve it as a really small team with low resources. So first of all, just kind of talk about inspiration. It's kind of interesting. You actually can think of Facebook as this giant primordial soup. So if you remember AP Bio class, there's tons and tons of people on Facebook, billions, using it for a lot of time. And they're actually experimenting all the time. So out of this, kind of like these little behaviors emerge, or these little trends that go viral, that actually make you think about the product in a different way. So to give you a concrete example of this, way back in the day, Facebook was just a directory, right? Like it just had, where you went to school, where you're born, stuff like that. So there's no way to actually like project or kind of like broadcast to the community what you're up to. And so what users kind of like hacked into the product was they just changed their profile pictures all the time as like a form of status update. So if you graduated or went to a party or at a coffee shop, you'd update your profile picture because that was the main thing that was shown around the site. So this actually inspired the idea of status updates, and this is like kind of the newsfeed beginning that we all know and love today. Now this still happens today though. So just even recently, a ton of users started updating their profile pictures to this like red equality sign to represent marriage equality. And this kind of went viral and made us think like, wow, like people are actually using their profile pictures even today as a kind of a form of communication or a form of support. So for Pride, we built this like rainbow overlay tool. And by making the product a lot easier and a lot more seamless, it 100x or 1000x the adoption of the product and totally changed kind of how people think about the platform. So we actually do the same, or we thought about the same thing for safety and disasters. So for broadcasting safety, users would kind of like make these little status updates and say, hey, some earthquake just happened, I'm okay. Here's my status, like here are my family members. A ton of people are asking me if I'm okay, so instead of responding to each person, I'm just gonna make a status update. But this product isn't as good as it could be, right? It's really unstructured, you don't get like a list of everyone who's affected, and this like not all your friends might not see this. So some people might still be wondering if you're okay. So we actually kind of like thought about this and came up with Safety Check. So just as a real quick overview of the product, if you're in the area affected by a disaster, we'll actually send a push notification to you. So once my video starts playing, oh, live video. Okay, there you go, sweet. So you'll actually get a notification from us, a push notification asking if you're okay. All you have to do is swipe up on that notification, you get this giant I'm safe button, and once you tap that, you've marked yourself safe. We'll actually go out to all of your friends once you've done that and let them know that you've marked yourself safe. So here, one of Claire's friends is browsing newsfeed, he gets a notification, he's like, wow, she's marked safe. I can see all my other friends who've been affected by this earthquake and who's checked in so far. And you can comment and like on these statuses to get like further details of people's statuses and their like level of safety, I guess. So this product, was really, really cool, but one of the interesting things is like we have this outreach step actually. So we actually need to go find all the people affected by a disaster and send them a push notification. Because this experience is way more powerful if like Facebook reaches out to you and asks, hey, are you okay? Than if you just like open up Facebook randomly and you get this like banner at the top. So a lot of people are already thinking, hey, this is just like a geolocation query, right? So we have this arbitrary part of the world, and we need to find the millions and millions of users that might be in that area right now. And this could be a country, a city, a state, a region, a zip code, whatever it is. So a lot of engineers were like, hey, this is an index, right? This is an interview question, dude, super easy, build an index, QED. But it's actually not that hard in practice, right? So users are constantly moving in and out of areas. So even when you just drive to work, you're gonna go through, 10 zip codes, maybe 3 cities. So this index, even if we built it, would be constantly stale. Even if we updated it in the right path, it'd be really expensive. If we did it async or offline, it'd be constantly stale. Also, it'd be huge, right? It'd be 1.5 billion users for this index of country, city, state, and also zip code, and maybe even finer in the future. And this is one of the really interesting things about building this product is that just the resources, right? We were a really small team with an unproven product, and we could, as Facebook, a company, throw millions of dollars at this problem and hundreds of engineers and stuff like that. But we were just unproven, right? We had to build the product and show its success before we could even get the resources to build a product. It's this weird kind of like chicken and egg problem. So we had to solve it at scale efficiently. Now we even want to do even further than that. So we wanted the query to be totally dynamic, no like necessary kind of preparation ahead of time, because I'm a really lazy engineer and I'm not going to maintain some pipeline that is never used except for the one day it breaks, which is when there's an earthquake. So we wanted to be dynamic and also instant. So the way we solved this was actually pretty interesting. We ended up leveraging the actual shape of the social graph itself and its properties. So I'm going to like animate out kind of how our algorithm works. So we have this area of the social graph that's people in Nepal or whatever earthquake area we have. And when we turn on safety check, we turn on this hook, essentially, into every single newsfeed load. So now, once our code starts executing, all these users start popping up. And these are people checking newsfeed, in anywhere around the world. So for people outside the area, they're not in Nepal, so we don't do anything. But as soon as we find one person inside Nepal, or whatever area we're interested in, then our algorithm really starts to kick in. We fan out. So we start fanning out to all their friends. Now, we might find a friend who's not nearby, who's not in the area, in which case we don't do anything. But as soon as we find one person who's also in the area, and then we send them that notification, that push notification, asking if they're OK. And we continue this process. So we fan out to a ton of people, send a bunch of notifications. And the real kind of next step here is we do this recursively. So then, for all those people we found inside the area, we fan those all out to different jobs or different machines and continue this process. So this ended up actually being really effective in practice, but there's kind of some interesting qualities around it. So first of all, why does this even work? Why does newsfeed loads, why is that a good thing to leverage? Well, you can actually think about it as a service that gives you a really random sampling of users that's also biased for the most active users who have the most friends, which is convenient. And it filters out all inactive users. So we have billions of rows of old test users and old data in our database. So if we actually look at a database-based approach, we'd have to filter out all these inactive people. But if you look at a newsfeed approach in the product, you actually get this really nice random sampling, this biased random sampling out of the box for free. And also it was 3 lines of code, so it was pretty easy. Next, this also works really well because the graph is so dense and so connected. If you think about the average distance between any two people on Facebook, illustrated here, we actually measured this, right? Everyone says 6 degrees of separation, Kevin Bacon, all that stuff. But we actually measured it, and on average, it's 4.74 edges. So if you start on average with any arbitrary user and go 5 hops away, you've explored the entire user base of Facebook. And we have 1.5 billion users. So it's pretty insane, and because the graph is so dense and so connected, we knew if our algorithm could survive 4.5 hops, we would probably do a really good job. So that's kind of some interesting reasons of why it was actually effective. But once we made it distributed, we kind of found these other issues. So if you're kind of thinking about this algorithm not running on a single machine, but instead distributed, we have this huge graph of all these people who use Facebook, and we want to explore them. So as we're exploring out kind of the shape of this tree as we find people, if you want to visualize this, you can kind of think of it as a tree. So the natural kind of point to do distribution is for every user, when you go to your friends, just fan them out to all these different machines. So that's kind of what that looks like. So you get a ton of parallelism for free, which is awesome. But the issue is that you kind of run into race conditions now. So one of the top race conditions we ran into was 2 machines in 2 different data centers had a user who was friends with the same person. So these 2 edges, they're both going to follow these edges and both find the person's in Nepal and send them a notification. Now, we thought we kind of ignore this just as a product team. You get 2 notifications, not that bad. But in employee testing, people said this was really stressful. They thought since they got 2 notifications, they were in trouble, or we were so worried about them, we sent them 2 at the same time. And it also, the last thing you want to feel buggy is a product around safety for earthquakes and stuff like that. So we had this extra high bar. So first we started relying on database kind of persistence layer stuff. So once we found that person, we kind of flip a bit in MySQL and just make sure the other machine didn't check it. But we have a distributed data centers, right? So some data center in Europe is running on this job, and some data center in the West Coast. And so because of a propagation delay, it took way too long to kind of like figure out if this person was invited yet. So we kind of had two layers. We have a database layer, and we have actually an in-memory locking structure as well. So as soon as we find that person, we set both bits. As the database layer is kind of propagating over between all of our data centers, the kind of like in-memory TTL is still alive. So this other machine tries to invite them and then has to abort the job. So yeah, and actually in practice, this ended up being like crazy effective, kind of to my surprise, because we tested it on employees, kind of like untested. So one of our first launches for a small typhoon in the Philippines, you can kind of see this like immediate jump in us not only finding people, but also people marking themselves safe, and then marking their friends safe too. So one of the actually nice things about this is like the product feels live. Because the algorithm is so fast and can find people so quickly, everyone in one single room opens up their phone. They've all gotten the notification. And then everyone starts marking themselves safe and their friends safe. So the entire product experience is really improved if you have like this feeling of like live and if it's really instant. Now our biggest launch was for Nepal. So in just under 5 minutes, we invited 3 million people, but we actually checked over 1 billion rows. There's so many people in Nepal for that earthquake that we actually like fanning out to all their friends. We've explored, 2/3 of the user base in just under 5 minutes. So it's actually this interesting, like really effective algorithm. And it's this interesting thing where like we were, as a small team, couldn't kind of like build a huge pipeline, build a huge index, but write some hacky PHP and kind of get the job done and have it be effective at scale. So now Brian's going to talk about generalizing mass messaging for all teams at Facebook.
All right, thanks, Peter. How's everyone doing? It's late in the day. Well, today I want to talk about how we generalize mass messaging, but I want to start with an experience that I had. Peter just talked about Nepal. Let me rewind the clock back to 2011. Or, let me go back. So this was 4 years ago. I was an engineer working in the offices of Facebook Japan in downtown Tokyo. It was a warm Friday afternoon. The date was March 11th, 2011. I was working at my desk when suddenly my monitor started shaking, and I was experiencing the largest earthquake in Japan's recorded history. Now, over the next several days, the effects of the tsunami and the nuclear disaster at Fukushima would become evident. But what I remember most was what happened to me later that day. The train system shut down, and I had to walk home. And during my hour-long walk home, I saw the streets flooded with people, of course, because millions of people were like me. They couldn't get home. They were stranded. And the cars, they were lining the streets. It was like a parking lot. Nobody was moving. But what really impressed me was that none of the cars were honking, and none of the people were looting. And in fact, as I was walking home, there was a shopkeeper. And this shopkeeper had a tray of green tea and gave me a rice ball. So this small act of kindness, as well as seeing the way the Japanese people really face this crisis with dignity, touched me. And I was moved to want to do something. And so what we did was we quickly put up a bulletin with links to official information, as well as Google's Person Finder. And immediately, I began to wonder, what could we do better? And now, we're not providing anything new here. And what can we do? What is our role here in providing information to these people who are in need? And so that was the thinking behind Safety Check. And as you saw with Peter, what we realized is that the social context is missing, that human layer or lens that really grounds an experience and brings it to life. And we also realized that we could bring it to other realms. We could bring the world together to contribute to people in need after a major disaster. We could also improve our democracy. We can provide social proof for participating in elections. And we can even bring a community together in order to find a missing child. This is with Amber Alerts. So this is the basis for generalizing mass messaging. But as I was building the first version of Safety Check, I ran into some problems. The first is that fragmentation over the desktop, mobile web, and native apps was creating a huge headache. There's enormous complexities with managing the content, the features, and the operations across multiple platforms. Additionally, we wanted to personalize the content. But even doing something as simple as Dear John would require hand-coding the entire message. And when you go that approach, suddenly it's really slow, tedious, and error-prone. And perhaps most troubling, and I guess Peter hinted at this, when you're dealing with a system that's only on during an emergency, you really want to be sure that it works. And it was hard to tell if it would work when you needed it to. So let me share with you first some of the lessons that I learned when building this system and hopefully making it cross-platform, simple, and reliable. So let's start with cross-platform. So the model I adopted was to have the server responsible for the text and images, as well as configuration information. And the client would perform prefetching of the data, as well as perform real-time invalidation, and finally, responding to client events natively. Now let's double tap into the real-time invalidation aspect, since that's the most interesting part. Now, whenever you're dealing with prefetched data, it's important to specify when that data should expire. So let me give you an example. Let's say that a user opens the app. The app prefetches some data, but then they close it before the app has an opportunity to show that announcement. Now, when they open it again a couple days later, and let's say it was an election announcement, you really don't want to show it then. So we specified this using a time to live, or TTL parameter, which is pretty standard. And this would tell the client how long they can use that data before it needs to be refreshed. Secondly, the number of times a user sees or interacts with a unit, what we call impression or action counts, need to be checked on the server. And this is important so that you have persistence across different devices. But just as importantly, you need to double check it on the client. And this is important because if the user has bad network connectivity, you don't want to show it to them more times than you intended to. And finally, we found it really helpful to add additional optional checks, or what we call filters, and these can depend on local device state. For example, if the server sends down a filter of type remaining battery percentage with a value of 10, this can instruct the client not to show it if the user has low battery. Instead, we can postpone it to a better time to show it. Enforcing content limits is also a little bit tricky. Now, when I was first designing views in a native app, I would specify the maximum number of lines for text. Then I learned why that was a bad idea. When you translate a string into other languages, sometimes it grows dramatically in length. This is a common example. This string, which is used by the safety check, is 35% longer when translated to Tajik, which is the language spoken in Tajikistan. Now, when you take into account that different platforms and different devices also have different screen sizes, now suddenly it's really hard to reason about when it's going to show up correctly or not. So a better approach is to define the content length restrictions on the server, and additionally, to build in a buffer to account for long translations. Let's move on to the next section. We wanted to build a simple system, but then we ran into difficulties incorporating dynamic content. So in the screenshot on the left, the user's name is dynamically inserted into the message. And in the one on the right, the carrier's name is also used. So what we did is we came up with a simple language to specify dynamic content. Take a look at that screenshot of the safety check announcement. It asks, "Are you okay?" And then the name of the crisis, the Nepal earthquake, is represented by crisis:"name" in curly braces. And we can also represent the permalink URL using crisis:"permalink URL in curly braces. So this is the syntax for the simple language that we introduced. The first argument is for the parameter provider. The second is for the name of the parameter. Now, parameters generate content at runtime, and they can be embedded in other content. The parameter provider groups logically related parameters together, and also it provides common data fetching and initialization. So for example, at runtime, you have contextual arguments like the viewer's user ID, as well as the trigger, being passed into the piece of code that's specified by the parametric provider and name. In this case, the crisis parameter provider and the crisis name, which helpfully resolves this to the Nepal earthquake. And in the final section, we'll cover reliability, specifically how we can deliver reliably even at peak capacity, as well as how we can gain confidence that our system works when we need it. So, of course, caching is a given for any system that runs at scale. In particular, positive caching and negative caching are both important in our use case. So positive caching, for us, is where you remember the units that were previously eligible, and negative caching is when you remember that no units were previously eligible. Let's take a look at an example. So safety check is a type of unit where we maintain a fixed channel of communication with the user. For the duration of the event, there are no view limits. So for example, if you turn it on Friday, there's constant delivery until you turn it off on Monday. Positive caching benefits this type of long-running promotion because you don't have to evaluate the eligibility of any other of the units. However, you do need to recheck the eligibility of any cached units because you don't want to show it any more times than intended. Let's take a look at another type of unit. So Amber Alert is a type of unit that broadcasts a one-time message. And the load profile for this type of unit is really different. For example, if we turn it on at 8:50, by 9 o'clock, we've already reached peak delivery. And then it decays really quickly. After 1 hour, we've reached half. And then by 3 hours, we've almost fully reached the target audience. Negative caching benefits short-running units like Amber Alerts. And this is because most of the time, there are no eligible units. With negative caching, it's efficient because we can remember that fact. Cool. A key aspect of any reliable system is knowing that it will work when you need it to. So how do we gain confidence in our system? What we did is we tested it end-to-end with a flag that kept it hidden from our users. And this allowed us to stress test it for 24 hours. And we're able to uncover unexpected issues. For example, when we did this the first time, what we call a dark launch, we were able to find insufficient capacity in one of the subsystems that generates social sentences, like the one pictured on the right. If we hadn't done this sort of stress testing, we wouldn't have known what would fall over when we did it for the real time. And one final note about load. Facebook is comprised of hundreds of interlocking systems. And sometimes, in the case of a catastrophic failure, you need to shed load quickly. For this reason, kill switches are important so that you can quickly turn off an entire system. Additionally, specific app versions or devices may have known problems, and a kill switch is really convenient in these cases for blacklisting them. Cool. So we answered 3 questions today. What kind of server-client model should we adopt in order to build a system that's cross-platform, but still responds natively? How do we incorporate dynamic content in a simple way? And how do we deliver reliably? And make sure that we have confidence in our system. To conclude, 4 years ago, after the events at Fukushima, we wanted to do something to help. But rather than posting informational bulletins, we realized that what we could provide was to give people a human lens over the events that were happening to the world around them. So I want to leave you with this thought. Instead of taking the conventional route, think about the unique role that you and your company can play. If you do so, I'm confident that you can solve real-world problems in a way that only you can. Thank you.